So can we introduce new healthy and sustainable food to the market without fueling the increase in food allergy? Unfortunately, I don't have the answer, but we will, without any doubt, introduce new allergies as we introduce new food. The question is, how much are we willing to accept, and how much are we willing to invest to develop new tools and strategies that will allow us to predict the allergenicity of our future food? We believe that the issue is not to avoid introducing any foods with an allergenic potential to the market, but more to avoid introducing a new peanut. So some of the food that we'll introduce to the market will be regarded as novel food. And EU law states that such foods should undergo a safety assessment. A part of this safety assessment is an assessment of the allergenic potential, as all foods containing proteins is by default assumed to be containing some allergenic potential. However, this is also a challenging thing, as there is no real guidance on how to assess the allergenic potential, and the tools that we have available are very limited. However, as you can see in the upper right corner, the amount of food and novel food applications that EFSA have handled have increased tremendously since 2017. So what makes a food an allergenic food? We don't know, but for sure some foods are more allergenic than other foods, and some proteins are more allergenic than other proteins. And for many years we've been talking about the big 8, which are the 8 groups of food that account for almost 90% of all the food allergic reactions. These are nuts, peanuts, milk, egg, fish, shellfish, wheat, and soy. And those are kind of the current main food allergies. But recently there have also been reports on what we call emerging food allergies. And these are both from food that we have been eating traditionally, like pea and sunflower seed, but also some of the foods that have been introduced more recently, like lupin and hemp seed. But what is kind of common for these is that we have increased our consumption of these, but maybe also the form and the way that we eat them. And what would be the food allergies of the future? Will it be grass allergy, insect allergy, seaweed allergy? I mean, only the future can answer this. So food allergy is divided into 2 phases, a sensitization phase and an elicitation phase. So sensitization happens often as first exposure, which involves a cascade of events in the immune system leading to the production of specific IgE antibodies. At this time, a person is said to be sensitized, but do not develop any reactions yet. Not until the next time the person sees either the same proteins or very similar cross-reactive proteins. Here the patient will experience an allergic reaction, also called elicitation. So when we look into the allergenic potential, there are 2 different scenarios we need to look into. That is de novo sensitization, meaning what would be the risk of us introducing a new food allergy? And cross-reactivity, meaning what is the risk of patients already having an allergy that they will experience an allergic reaction when they start eating this new food. So whereas we actually have tools available to evaluate the cross-reactivity, the tools are more or less lacking for us to evaluate de novo sensitization. However, if we go into the cross-reactivity, what do we actually do? Of course, we can look into the taxonomic relationship of our new foods to known foods with an allergenic potential. We could look into the proteins, the amount of proteins. We can look into the stability of the proteins, how resistant are they to digestion, to heat treatment. And if we know the amino acid sequence of the new food proteins, we can do homology search, see how similar are the proteins to no allergens. If we know the patients that would be in risk, we can do serological testing in order to see how well their IgE antibodies react to these new food proteins. And if we have fresh blood, we can also incubate the new food with their effector cells to see if the effector cells will degranulate, release mediators, which are the ones responsible for the allergic symptoms. But if we don't have any patients available, what we can do and what we are doing in our research group is to kind of make simulated patients in our brown Norway rats. And so we did in order to evaluate what would be the risk of eating quinoa if you had different kind of food allergies. So here we made simulated patients in our animals by immunizing them with different kind of nuts, with peanuts, with milk, with soy, with wheat, and with different pollens. And what we could see was that for most of these animals, they did not really recognize or react to these quinoa proteins. But some of the animals, those which were immunized with nuts, they could actually recognize the quinoa seeds, and especially walnut. So this may indicate that walnut allergic patients could be in risk of having an allergic reaction if they started eating quinoa seeds. Now the more challenging part to look at de novo sensitization, where we actually have no validated tools. So what can we do here, and what do we do here? We can look into the proteins if we know the proteins, because even though we eat hundreds of different proteins each day, the allergenic proteins more or less fall into some superfamilies of allergenic superfamily proteins. For many years, we have been doing simulated in vitro digestibility assays, and that we've done a lot of research into, but it seems like this assay is really not that predictive, as even small peptides may indeed sensitize. So again, what we've been doing in our research group is to use our animal models, as the brown Norway rats resemble atopic humans in their predisposition to develop allergy. So here we evaluated new foods against known non-allergenic or low allergenic foods and against highly allergenic foods. So as an example, we looked into the sensitizing capacity of black soda fly larvae, microalgae, quinoa, and rapeseed cake, and compared that to the non-allergenic pork gelatin, spinach, and the highly allergenic peanut. And what we could see was they could actually rank these 4 different new foods in between the non-allergenic and the highly allergenic foods. So as you can see, the black soldier fly larvae, they were kind of having a low sensitizing potential, whereas the rapeseed cake has almost the same, or actually the same level of sensitizing capacity as the peanut. Another thing that is having our increased attention is to develop new in vitro cell-based assays. Cell-based assays resembling the key events of the sensitization. And by this, hopefully in the future, we will be able to make an adverse outcome pathway. And if you are interested in knowing more, please visit our stand. And with this, I would like to thank you for your attention.